This session is for OCR FP2. The topic is Maclaurin series and we're looking at June 2010 question 2. So looking at the question first, it says that we're given the first three terms of the Maclaurin series for 1 plus sine x upon e to the power of 2x are identical to the first three terms of the binomial series for 1 plus ax to the power of n. Find the values of the constants a and n, and it reminds us there that we can use our formula books for the Maclaurin expansion and what we'll want is for sine x and e to the 2x. So if we just do that, then substituting in those expansions, and we only need the first three terms, then 1 plus sine x is going to be 1 plus, and the series from sine x will be x minus x cubed over factorial 3. But actually we're not going to really need that one, so we've just got that bit. And then the formula for e to the x is going to be 1 plus x squared over factorial 2, but we're replacing, everywhere we have an x, we're replacing by a 2x. So we'll have 1 plus 2x plus 2x all squared, which is 4x squared, over factorial 2, which is 2. So bringing those terms together, so we'll have a 1 plus a 2x plus a 2x squared when we multiply everything in the second bracket by 1, and then we'll have an x plus a 2x squared, and that's all we'll need when we're multiplying everything in the second bracket by x. And bringing the terms together, that gives us 1 plus 3x plus 4x squared. So those are our first three terms, and then what we're going to do is we're going to do a similar sort of thing now. We're going to find the first three terms in the binomial expansion of 1 plus ax to the power of n. So that's going to be 1 plus an plus n upon n minus 1 over factorial 2 a squared x squared, and just be careful there that you remember to square the a. So looking at those two series, we've got a constant of 1 in each of them, so what we now need to do is to look at the coefficients of the x term and the x squared term, because they will need to be the same. So for the x term, we have a 3 up here and an an x, which I for some reason or other didn't put in there. So we have 3 equals an, and then looking at the x squared term, we have a 4 in the first series, and we have an n upon n minus 1 over factorial 2 a squared. So two equations in a and n, so we just need to solve those simultaneously to find the values of our constants. So looking at that first one, if 3 is equal to an, then that means that a is equal to 3 over n. And substituting that into this second equation, we'll get 4 equals n upon n minus 1 over 2, and a squared now will be 9 over n squared. And if we simplify that through, you should end up then with a quadratic. So we're going to get what? 8n squared on the left equals 9n squared minus 9n. And if we simplify that and factorize it, you'll end up with n upon n minus 9 equals 0. So we know that n isn't going to be 0, so that implies that n equals 9, in which case a is equal to 1/3. So we've now found the constants. If we just have a quick look at how the marks are awarded for the question, you got 1 mark for expanding up here, the 1 plus sine x, and then you also got a method mark for the e to the 2x, and then an accuracy mark for bringing those two together to get 1 plus 3x plus 4x squared. You got a method mark for expanding and getting the first three terms using the binomial expansion. And then in terms of finding the constants, there was a method mark for getting your two simultaneous equations correct and an accuracy mark for the answer at the end. So 6 marks in total for the question. So don't forget that if you want to watch further revision videos, then you can access those by going to the Further Maths Support Programme website and following the link.